This video is a demonstration of the application CancerVis, an effective visualization tool of Cancer Signaling Network. The signaling network is combined with various data sources, including pathways from Reactome, oncogenes and hallmarks from cosmic and approved cancer drugs. The dataset is stored in Graph Database Neo4j. The goal of this application is to visualize the rich attributes in the cancer signaling network and reduce the cognitive load of the visualization. User can select nodes and edges to visualize according to edge attributes. The legends indicate the color coding of the edges. User can use the control panel to adjust the size of the network. The nodes have multiple centrality measures as attributes. User can select one of them to visualize. Color and size of the nodes varies according to the selected measure. The slider can be used to filter the nodes by setting the lower and upper bound of the attribute. User can also access the histogram of the measures. Both linear and logarithm scales are available. By clicking on a bar in the histogram, the nodes with attributes within the range will be displayed in the network. User can filter the genes using other node attributes. User can choose to visualize the network of oncogenes and drug targets. Pathways are ordered in hierarchical order in a tree list. By selecting one item, the network of genes within the pathway will be shown. User can look up the position of genes using the search bar. When the target is found, it is highlighted together with its neighbors. When a node is selected, a context menu will pop up, and user can query the attributes of the node. The Entree ID, name, related drug, hallmarks and oncogene attributes will be listed in the side panel. User can also query the parent pathways of a gene. The ID and name of the pathways are displayed. User can view the neighborhood of a node by clicking on one or two hop neighbor. The pathways and their relationships are accessible using two layouts. By selecting Pathway Network, the network will be displayed in a new window. Each node represents a pathway. An edge exists between two pathways that have common member genes. When hovering on a node, its connections with other pathways are highlighted, and the name of the pathway will be displayed. User can double-click on a pathway. The member genes will be displayed in the signaling network. The hierarchy of the pathways are presented in circle pack layout. When hovering on a pathway, arcs are drawn to connect it with other pathways with common member genes. The connected pathways are also highlighted in the tree list on the right. When double-clicking on a pathway, member genes on it will be displayed on the signaling network. With the subnetwork icon, user can select a subnetwork by exact nodes, neighborhood of nodes or the nodes currently visible in the network. If the second is selected, user can input a list of gene names. They are included in the generated subnetwork along with their one-hop neighbors. The subnetwork will be displayed in a separate window. User can use the icon to see the legend, use input fields to search path between nodes, and use slider to adjust cognitive load. To reduce cognitive load, the commonly seen motifs are grouped into different glyphs. More nodes are grouped together when the cognitive load is further reduced. To find a path between node pairs, user provide the names of the genes, and the path is highlighted in red. Subgraph can be generated using currently selected nodes, the cancer genes in this example. When hovering on a glyph, the information of the group will be displayed. By clicking on it, the glyph is expanded. The V-shape represent pathways, hexagons are cliques, diamonds are connectors, and triangles are fans. User can predict target combinations by inputting the size of the combination, number of combinations to retrieve, and uploading a set of oncogenies. The results are displayed in a table in the side panel. The user can select the combinations, and the genes will be highlighted in red. The combinations can be viewed together with other node attributes, such as the centrality measures. In conclusion, CancerVis enables users to explore the cancer signaling network by multifaceted visualization on its rich attributes, and uses motif simplification to reduce the cognitive load, which may be useful for cancer-related research.